So I welcome all the members for the today's research lecture series under latest research trends in mechanical engineering. So in today's segment, we are going to discuss about use of AI systems in core mechanical engineering. Particularly, we are going to see about material science and metallurgy. So in that, we are going to discuss about the selection of material composition, the most optimal selection of material composition for uh, alloys used in aerospace application with the help of AI-driven systems. Now let us discuss the topic objectives. So with the use of machine learning models, we can easily predict the core fundamental mechanical properties as well as physical and the thermal properties of the material. So what are all the mechanical properties? Say strength of the material, hardness and ductility, corrosion resistance, the Young's modulus, say modulus of elasticity. So these are some of the core fundamental the material properties. So using this, how can you develop a new composition, a material composition with the help of the machine learning models? And these machine learning models will give you the accurate solution with a minimal error difference of 10% by aligning according to the experimental data. At the same time, AI can also solve simultaneous multi-objective uh, conflicting properties, say maximizing the high temperature strength. At the same time, we can able to improve the room temperature ductility for refractory high entropy alloys. These problems comes under multi-objective parametric optimization. So in continuation with the topic objective, now we will move on to the subject theme. So here in today's the lecture series, we have took the common theme as AI driven application. So AI driven technology supports a lot for material science and metallurgy in order to predict the quality of the material composition by reducing the cost of rejection of material due to poor quality and so on. At the same time, we can able to improve the strength and other aspects of the material with the help of the so-called the machine learning, the training models. Whereas the conventional trial and error method has lot of defects and it is a time consuming process. It may take several months or several days to predict the ultimate composition of the material. Whereas the AI driven system will try to get a solution within a week time. So by leveraging both machine learning and artificial intelligence model, so it requires a huge, vast amount of data sets to predict the material properties and identifying the best possible the composition elements of the material within a fraction of time. Now let us see some of the methodologies and techniques. See algorithms like random forest regression, gradient boosting trees, and artificial neural network. These are some of the standard methodologies that are applied to do the experimentation and simulate the data by predicting the material properties, say hardness, strength, and fatigue life of the material. So using the AI models, we can generate new alloy composition by meeting out the specific target properties of the material rather than just predicting the properties for a given composition on trial and error method. Now let us see some of the application of AI in different sites. Let us take high entropy alloy. Here, due to the complex nature and multi-component future, so it is more difficult to design traditionally. So with the help of the AI, we can able to study the phase stability and identify the single phase ductile high entropy alloys under various environmental conditions. Recycled aluminum alloys, sustainable and recycled aluminum alloys. In this case, AI helps to manage the level of impurities present inside the material. So here we have to control the impurity fluctuation by recycling the wastage, by predicting the impact of impurities, say iron and silicon. So by reducing these impurities, we can able to improve the microstructural integrity by properly balancing the addition of the material composition by doing the process as per the logical workflow. Let us see some of the key benefits of using AI technology in core mechanical applications, say material science and metallurgy. So reduced development time and cost. So AI reduced the time required for new alloy discovery from months to week. AI can also identify the non-intuitive process for superior alloy composition, whereas the traditional method it is not there. AI optimize the proper balance between competing properties, say strength, by reducing the material density. So these are some of the key advantages or key benefits in AI technology for solving the complex problem related to core mechanical engineering issues. So what are the challenges of AI integrated systems in mechanical engineering problems in real time? So data scarcity and quality. So we require an effective AI model in order to support large, huge amount of data, maintaining high quality and standardized data sets. Say, for example, advanced aerospace alloy. Here, the information that we are going to fit into the AI model is a prime importance. Then interpretability of the results. Understanding the physical mechanism behind the AI predicted results, so that can be easily understood by with the help of explainable AI systems. Then validating the experimental data. So from the AI driven findings, we can easily able to understand the predictive power of the AI model for the new alloy determination of material composition. Now let us see some example case study. So here in this case study, we are going to discuss about nickel-based super alloy for a jet engine turbine blades. So the problem is the aerospace manufacturer wants to manufacture a new turbine blade alloy, which is fully composed of nickel-based alloys, super alloys. And this is the operating temperature. The material should sustain at the temperature rate greater than 1050 degrees centigrade. At the same time, the material must reduce the rupture, that is the creep resistance, and we have to control the density of the material. So these are some of the problem statements that are given here. Now let us see how AI, the training model, going to support in solving the mechanical problem, the practical problems in real time. So first one is we have to make a data set creation. So add n number of huge vast information about the prehistorical data trend of nickel based super alloy into the system. and prepare the random composition range of nickel-based alloy according to the existing literature. And these are the properties the material must have: less uh, creep resistance, sorry, high creep resistance, more volume fraction, less density, and phase stability. So these are the properties the material must have. Now develop an AI model in order to predict the above information. So measure the creep life of the material, whether it can able to withstand the temperature limit of 1050 degrees Celsius, and also measure the density of the material by comparing to the standard data. So these are the conditions applied. So there should not be any brittle phase to be formed while preparing the composition of the material. And the density of the material should be always 8.7 gram per centimeter cube. And it should have very good oxidation resistance. So these are some of the constraints applied for a nickel-based alloy. So by feeding all this information into an AI model, it will try to solve repeatedly and it will predict the results. So this is the AI generated alloy composition for a new material, nickel-based alloy. So these are the different ingredients that comes under along with the base nickel alloy, and the relative balance percentage weight for each elemental composition are tabulated here. This will be taken as a final the composition matrix for a new material, and later on it will be implemented in real time for foreseeing the manufacturing operations subsequently. And these are the predicted performance of the new composition by comparing with the existing standard data with the AI generated solution as given here. So above all, so it is proven that the developmental time, that is the solution developmental time using AI model, is reduced by 70% rather than compared to a normal trial and error manual method in material composition preparation. Then cost savings in testing and materials. So now it is highly suggested to fully convert into a final product for a full scale the turbine blade the trial production. So these are the outcome of the case study as presented here. Now with this I conclude the entire lecture in nutshell. AI models can able to generate n number of potential composition in a fraction of time. With the help of the machine learning algorithms, so that can able to predict the mechanical properties with the less error margins of 10 to 15%. So the use of AI technology is very much helpful for solving classical mechanical problems in real time. So it is used as a very good forecasting model in order to challenge any type of the practical problems in core mechanical engineering. So with this information, I propose my formal acknowledgement or vote of thanks to all members, whoever I have mentioned here. First, I propose my formal acknowledgement to all senior professors in mechanical engineering for giving some insights about the importance of AI integration in core mechanical engineering. Next, I acknowledge the present student batch of mechanical engineering studying from various engineering colleges. So they have given the constant support. Last, I acknowledge the family members, my parents, have given me vast enough resources to me in sharing this knowledgeable content to various audiences. So with this, I thank each and every one of you. We will meet in the next subsequent upcoming lecture series under latest research trends in mechanical engineering. Once again, I thank all the members. Thank you all.